Hi, welcome to the video for the net ionic equation practice or exploration. As you're watching this video, be sure to pause it when you need. This video will model a couple of practice problems for you so you know what you're expected to do, and it will also reveal the answers or the work for each of the practice problems that you have. So before we get started, I want to just remind you what a net ionic equation is. They're simplified reaction equations that show which ions change during a chemical reaction. And they really just help you to focus on what's actually changing. And remember, that's the thing about a chemical reaction. It's a chemical change. So the steps for writing net ionic equation are as follows. First, you're going to write the balanced chemical equation, also known as the balanced molecular equation. That's the sort of balanced chemical equations we've been writing the whole entire time, where everything is shown as molecules and we use coefficients to balance them. The next thing we're going to do is write the complete ionic equation, and we do that by splitting things that are strong electrolytes into their cations and anions. So you may be thinking, well, what are strong electrolytes? There are two things that we include as strong electrolytes. First, soluble ionic compounds, and that would include even metal hydroxide bases. Those are ionic compounds. So remember, if you use the solubility chart, we can use that to figure out which things are soluble if it has an aqueous symbol, or insoluble if it has a solid. So if we have a soluble ionic compound, we'll split it. If we're dealing with acids, we will only split things that are strong acids. And here are the 7 strong acids: HCl, HBr, HI, HNO3, H2SO4, HClO3, and HClO4. So if it's one of these acids that you have in your reactant or even on your product side, you would split it. You will, so for example, acetic acid, CH3COOH, it is not a strong acid, so we would not split it into ions. The next thing we do is we cross out anything that is an ion on both sides of the reaction arrow. And once we've done that, whatever is left, whatever does not cancel out, will form our net ionic equation. And the other thing we need to remember for net ionic equations is to make sure we include the phases. So anything that's an ion will have an aqueous phase, and whatever is kept as a molecule will either have a solid or a liquid phase for the most part. Weak acids will also have an aqueous phase as well. So to do these problems, you do need a solubility chart, so you can take out the double displacement reaction practice to access that solubility chart. Now we're going to go through examples. I'm going to model the first example for precipitate reactions, and then after that I'm just going to show you the answers. So here's what you should have for your first problem. It says write the net ionic equation for the reaction of potassium chloride and lead 2 nitrate. So you'll notice on your practice slides that you have the balanced molecular equation that's provided for you. So the good thing is you don't need to do step 1, but you do need to start with step 2, which, to remind you, is splitting the strong electrolytes in their cations and anions. So the ions are provided in these little cards at the bottom here, and these red slashes are for canceling out later in step 3. All right, so what I need to do is figure out which of these reactants and products I'm splitting. Now, these are all ionic compounds, so for ionic compounds, the only thing I need to do is look at whether it's aqueous, I will split it, and if it's solid, I will not. So let's take a look at KCl. I see that that's a soluble ionic compound because it's aqueous, so I'm going to split that apart. And the ions I use there are K plus and Cl minus. Now, because I have 2 of them, I'll do this twice, but notice what I did was I just dragged the ions that make up the molecule. And I'm going to do this twice, as I said, because there are 2, I have a coefficient of 2, so I have 2 KCl molecules, so 2 of them will split apart. The next thing is lead 2 nitrate, and for the lead 2 nitrate, it is aqueous as well, so I will split it apart to the ions. I would use the lead 2 plus ion and the nitrate ion. But the one thing to keep in mind is that, notice that there are 2 nitrates, I'm going to need 2 of those. Alright, so I have my lead ion, and I'm going to need 2 nitrates. I'm using this number outside the parentheses to tell me that there's 2. Okay, so that's that split apart. Now I need to go onto the product side. My first product is PbCl2, So lead 2 chloride. You'll notice here that it has a solid, so should I split that apart? No. But what I am going to do is I am still going to write it as a molecule. So to write it as a molecule, anything that does not get split apart, I'm just going to keep them together. Notice how all of these had spaces between them? All the ions have spaces between them. For lead 2 chloride, because it is a molecule, I'm putting them together. I'll put the lead in the middle since it's the positive charge and the negative charge is outside of it. I keep it all together as one molecule. So it doesn't, so I still use the ions, but I won't split them. And the last is potassium nitrate. And again, I have, this is made of potassium and nitrate ions. And I have 2 of them, so I'm going to need to do that twice. So here's my first potassium nitrate. Everything's split apart. And then here's my second. So when potassium nitrate dissolves in water, it's going to split apart into these ions. Okay, so that is the second step done for you, writing the complete ionic equation by splitting it into ions. So that's what you should have. Now, one thing I want to point out is we're doing this using these boxes, but I did want to show you another way of writing it. What you can do when you're actually solving these problems, you do actually write out the ions. You don't have to do this on your practice because there isn't really room for it, but I just want to show you what that looks like. And this is our complete ionic equation. Oops, sorry. So we have K plus, and I have 2 of them. I have Cl minus, and I have 2 of them. I have 1 lead 2 ion, and then 2 nitrate ions. Notice that the subscript that was out of the lead, outside of the parentheses there, becomes now the coefficient for nitrate, since it splits into 2 of those ions. And then for PbCl2, that stays together as a molecule because it didn't split. And then over here I have 2 K plus ions and then 2 nitrate ions. Alright, the last thing that we're going to do is we're going to use these red slashes here to cross out anything that's an ion on both sides. That is the last step, essentially, or the third step. So we're going to cross things out. So if I look at my reaction, I see that I have K plus, go back here, sorry. K plus is an ion on both sides. It's separate ions, K plus, they're separated. So I must go ahead and cross those out. My Cl minus, on the reactant side, it's separate ions, but on the product side, it's a part of a molecule, so I can't split it up. They have to be separate ions on both sides. Take a look at lead next. My lead ion is a separate ion floating around in solution on the reactant side, but not on the product side. So once again, I can't cross that out. But I can cross out my nitrates because, again, they're separate ions on both the reactant and product side. So I'll cross those out. And now what I have left is the only thing that really changes in the reaction, which is the chloride ion and the lead ions to form the lead chloride. All right, so let's take a look at that. So when I get rid of what I've crossed out, I have my net ionic equation. And so for your work, this is what your final work should look like. You should have all of your ions underneath the molecules. And of course, if it ionizes, you would split them up. And then you should also have things that are crossed out, so things that are ions on both sides. And then in the box here, I want your net ionic equation, whatever did not cancel out, you will put here. All right. Okay, so you're going to try this now for the next set of problems. Starting with problem number 2. And what you're going to do is you're going to pause the video while you work through it, and then I will show you the answers once you press play. All right, so now you should have, first thing you should have done is separated these out into ions, things that can be separated. The next slide, I will show you that separated. If you want to see the complete ionic equation, remember you do not have to write this. This is what it looks like. Next step, cancel anything that is an ion on both sides. Pause the video now and you press play again. I will show you what that looks like. once you have things that are ions on both sides canceled out, the next thing you want to do is write whatever is left as your net ionic equation. When you press play again, I will show you what that looks like. So this is the final answer for example 2. Let's take a look at example 3. So again, split things that are ions, that can be split into ions on both sides. Pause the video now, you press play again, I will show you what that looks like. If you want to see what the complete ionic equation, what that will look like written down, this is what it looks like. Now go ahead and cancel anything that can be canceled out. You'll notice in this case that everything cancels out. And so for your net ionic equation, you're going to write no reaction. So this is one of the reasons why we like net ionic equations, is because remember we said that in order for you to have a precipitate reaction, at least one of your products must be a solid. And this shows it. We say that there's no reaction here because all of the reactants, when dissolved in water, they don't change. They remain as ions on both sides of the arrow. So there's been no change here. So whenever you have aqueous products, two aqueous products in your precipitate reactions, everything will cancel out, and so you'll have no reaction, and there will be no net ionic equation. The next set of examples are acid-base reactions. Strong acids and soluble bases are one we're going to look at first. So remember, when splitting things into ions, for acids, you can only split the strong acids, which you have a list of them in your notes, into ions. If it's not one of those strong acids, you don't split it. So let's take a look at this example. I want you to try this one on your own. We have HCl, KOH, KCl, and H2O. And you can go ahead and pause the video, and then I'll show you what it looks like when it's split. Alright, so here's what it looks like when it's split. The acid splits into H plus and Cl minus because it's a strong acid. The base is a soluble base, it has that aqueous symbol there, so that splits apart into ions. So does the ionic compound, the salt product, KCl, splits apart because it's aqueous. But water, it's a liquid, it stays together as a whole molecule, so that doesn't split. Alright, now go ahead and try and cross things out that can be crossed out. Oh, let me just show you, this is what the complete ionic equation. Go ahead and cross things out, what can be crossed out. And when you press play again, I'll show you what that looks like. So the only things that can cross out here are the K plus and the Cl minus. And then write whatever is left as your net ionic equation. And this is what it should look like for example 1. Let's look at a couple more examples. So once again, you're going to pause the video when you need to, and I will reveal what the work looks like. Here's example 2. This is what it looks like when they are split into ions. And this is the complete ionic equation for that. This is what it looks like when they are canceled out, things that can cancel out. And here's our complete, or a net ionic equation. One thing you will notice here is that you may be thinking, oh, there should be a coefficient of 2 in front of the H plus and the OH minus and the water, because you have 2 of those ions and 2 waters here. But the thing to remember is that with these, with balanced chemical equations, you use the smallest whole number ratios for the coefficients. So a coefficient of a 2, and a 2 can be simplified to a coefficient of a 1, a 1, and a 1. Here's example 3. Here's what it looks like when it's split. Notice the product, barium sulfate, does not split because it is an insoluble ionic compound. And here's the complete ionic equation. In this case, nothing cancels out, so your net ionic equation is the same as the complete ionic equation. Now let's take a look at examples with weak acids and a soluble base. So remember, with weak acids, they also don't cancel out. So take a look at this and try and see what, go ahead and split things that can be split into ions. Here's the answer for that. You'll notice that acetic acid is a weak acid, so that does not split apart. All right, cancel things that can be canceled out on both sides. Oh, here's the complete ionic equation. And then go ahead and cancel things that can be canceled on both sides. Only thing here is a barium. And what you have left is your net ionic equation. Finally, sorry, there was an error in the coefficients. Once again, this could be simplified. So this is the net ionic equation with the simplified coefficient. All right, one last example. This one is with a strong acid but an insoluble base, so a base that does not dissolve. Go ahead and split things apart if you can. And this is what it looks like when they're split apart into their ions. Calcium hydroxide is insoluble according to the solubility chart, so we keep it together as a molecule. All right, that's the complete ionic equation for that. Now we're going to go ahead and cancel things out that we can. Only thing that cancels out here is the sulfate. And so this is the net ionic equation for that. All right, so I hope you found this video helpful to sort of visualize what happens in a net ionic equation. Remember, we split things apart that are strong electrolytes, that include strong acids and soluble ionic compounds. Everything else stays together as a molecule, and then we cancel things out that are separate ions on both sides. I hope you found this video helpful. Good luck with your work. Have a quality day.